Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. In today's video, let us discuss rationalization. Rationalizing is nothing but getting rid of radicals. Okay, we will start with rationalizing the denominator, particularly with one term. Let me take an example. Okay. When a radical contains an expression that is not a perfect rule, for example, square root of 3 or square root of or cubic root of 5. This could be a perfect example. It is called an irrational number. So, in order to rationalize the denominator, we need to get rid of all the radicals that are in the denominator. Okay, let us start with this example. As a first step, we have to multiply the numerator and denominator by a radical so that we will get rid of the radical in the denominator. If the radical in the denominator is a square root, then you can multiply by a square root. That will give you a perfect square under the radical when you multiply it by the denominator. If the radical in the denominator is a cubic root, then you can multiply by a cubic root. That will give you a perfect cube under the radical when multiplied by the denominator. And it goes on forth. In this example, we have a square root in the denominator. Then we need to multiply by the square root of an expression so that it will give us a perfect square under the radical in the denominator. Square roots are always good to work with in this type of problem, because if the radicand is not a perfect square to begin with, we just have to multiply it by itself. Then we get a perfect square. Square root of 6 times square root of 6 will give you square root of 36, which is nothing but 6. Okay, so in this case we can accomplish this by multiplying top and bottom by a square root of 6. Please look at the board. Multiply the numerator and the denominator by the square root of 6. Now let me show it on the board how we get a perfect square. 6 times 6 is 36 under the square root. So the denominator would become 6. We can simplify the fraction if possible. We have to make sure all the radicals are simplified. We can find the common factor between 4 in the numerator and 6 in the denominator. Common factor between these two is 2. Let us reduce the fraction. We get 2 root of 6 over 3 by dividing out the common factor of 2. We have to be careful when we reduce a fraction like this. It is real tempting to cancel the 3 which is on the outside of the radical with a 6 which is inside the radical on the last fraction. So you cannot do that unless they are both inside the same radical, okay, or both outside the radical, like 4 in the numerator and 6 in the denominator. Numbers outside the radical is different from the numbers inside the radical. I would like you to show one more example under the same topic, rationalizing the denominator with one term. Hope you see the question. Let us start with step 1. Multiply the numerator and denominator by a radical that will get rid of the radical in the denominator. By looking at this example question, we can say that we have a cube root in the denominator. So we need to multiply by the cube root of an expression so that it will give us a perfect cube under the radical in the denominator. So in this case, we can accomplish this by multiplying top and bottom by the cube root of 9a square. Let me show you the steps so you'll get a better idea. By applying the law of exponent, we can just rewrite the exponent separately for the numerator as well as the denominator. So this would become, hope you are clear with this step. Now let us rationalize the denominator. Multiply both the numerator and the denominator by the cube root of 9a square. While rationalizing, we will be frequently using many laws of indices, that is laws of exponents. This is just a fractional multiplication. So multiply the terms in top row and multiply the terms in bottom row, that is the denominator. Let us check whether the denominator has a perfect cube under cube root or not. The top row numerator would become cubic root of 18a square. Now the denominator, 3 times 9, 27. So the denominator would become, we have performed fractional multiplication. Now we have to make sure all the radicals are simplified or not. So we have to simplify the fraction if possible and give the lowest term as the answer. Please look at the board. We know that cubic root of 27a cube is 3a, because 27 can be written as 3 times 3 times 3. A can be written as a times a times a. So the denominator would become, as we discussed in our previous example, we would not be able to cancel out the 3 with the 18 in our final fraction, because the 3 is on the outside of the radical and the 18 is on the inside of the radical. So we cannot take the cube root of anything under the radical. So the answer we have is the simplified lowest term. So far we were discussing how to rationalize the denominator with one term. Now let us move on to the next topic, rationalizing the numerator with one term. As we mentioned earlier, when a radical cannot be evaluated, for example, the same example I'll take, square root of 3 or cube root of 5, which is called an irrational number. So in order to rationalize the numerator, we need to get rid of all the radicals that are in the numerator. Okay, we are going to follow the same basic steps that we used for rationalizing a denominator, but we are just applying the same thing to the numerator now. Okay, as usual, the first step would be multiply the numerator and denominator by a radical. That will get rid of the radical in the numerator here. One thing must be kept in mind, that as long as we multiply the numerator and denominator by the exact same thing, the fractions will be equivalent. Like how we make the equations balanced one. Whatever operation we are doing on the left side of the equation, we will do the same thing on the right side of the equation too. Same way, whatever number you are multiplying with the numerator, you have to do the same thing with the denominator too. Only then the fractions will be equivalent. Finally, as usual, we have to make sure all the radicals must be simplified and our answer should be in lowest term. So simplification of the fraction is needed wherever, whenever possible. Okay, let me take an example and explain you how to rationalize the numerator here with one term. Hope you see the question on the board. Okay, let us start with step 1. Multiply the numerator and denominator by a radical, so that we will get rid of the radical in the numerator. Since we have a square root in the numerator, then we need to multiply it by the square root of an expression, so that we will get a perfect square under the radical in the numerator. So in this case, we can accomplish this by multiplying top and bottom by the square root of 5. I'm just applying the law of exponent. I'm just distributing the square root for numerator as well as the denominator, and then I'm going to multiply both numerator and denominator by square root of 5. Always keenly note that whether the question is asking you for rationalizing the numerator or denominator, so you could work according to the instruction given. Now by multiplying numerator and denominator by square root of 5, we will get a perfect square under the square root. So the top row would become, and the bottom row will become 6 times 5. That will be equal to 30. Square root of 25 is 5. We have to give our answer in lowest form. As we earlierly discussed, we would not be able to cancel out the 5 with the 30 in our final fraction, because 5 is on the outside of the radical and 30 is on the inside of the radical. So we cannot take the square root of anything under the radical in this particular example. So the answer we have is as simplified as we can get it. That's it for this example. Okay, let us move on to the next example. This is our next example. Let me show you how to rationalize this numerator here. As usual, we have to start by multiplying the numerator and denominator by a radical. so that we have to get rid of the radical in the numerator. Please look at this question. We have a cube root in the numerator, so we need to multiply it by the cube root of an expression so that it will give us a perfect cube under the radical in the numerator. To get a perfect cube, we can multiply both numerator and denominator by cubic root of 4x square. Okay, let me show you the steps on the board. Hope you're clear with this step. Now apply fractional multiplication. Multiply the terms in top row first, that is in the numerator. So we will get cubic root of 2x times 4x the whole square. Denominator would be 5 times cubic root of 4x the whole square. Now let's simplify the answer. Cube root of 8x would be, okay, we have 8x cube in the top row. So cube root of this would be 2x. Denominator will be the same. Now you know that we cannot able to cancel out the 2x and 4x because that is not a common term. And we cannot take the cube root of anything under the radical. So this is the simplest answer. Hope you're clear with all the examples we discussed in today's session. In our next session, we can see how